Bienvenidos, Ushamdid, and welcome to another NetAcad Introduction to Python course supplemental video tutorial. In this video tutorial, we're going to begin our look at Lab 4.1.6.13, where we're actually going to be creating a tic-tac-toe interactive game, and this is going to be part 1 of a series of 5 videos. Now, there's a lot going on in this lab, and I'm sure that this is the lab that you've been waiting for, because this is by and far the most difficult of all of the activities we've had to do up to this point in the course. Now, part 1 of this activity, and the way I'm going to handle this, is for each of the functions that we're being asked to create that are part of this program, I'm going to be doing each of those in their own video, and in the final video, I'm going to be pulling them all together. So we're going to be sort of growing this solution as we go through this video series. And so let's jump in and take a look here at this activity. And so what you can expect out of this video is we're going to finish the display board function. Right? You can see the function accepts one parameter containing the board's current status and prints it out to the console. And we're also going to be reviewing some key topics and ideas such as namespace, scope of visibility. We're going to talk about working with lists and how we would work with lists that contain lists, and that's going to be extremely critical. And so let's go ahead and dive in here. If I was to scroll back up to the top, you can see they've estimated 30 to 60 minutes, medium to hard. I'm going to disagree with that. I'm going to say that for a beginning learner, this is going to be extremely difficult. Now, we've got some requirements here in terms of X's and O's, but here is what the board should look like initially, right? Where we've got these numbers here, 1, 2, 3, 4, 6, 7, 8, and 9, and the center space is always going to be an X because the computer always goes first and will always choose that center spot. And so based off of that, we should be able to come up with a series of print statements, and that's how I'm going to tackle it here initially, a series of print statements to get this board printed out in toto. All right, so what we want to do first is we want to scroll down just a little bit further here past all of the boards that they're displaying and take a look at the requirements. Now, they want us to create a list, and you can see right here, the board should be stored as a 3-element list. In other words, if I was to give an example here, let's pull up the Integrated Development Learning Environment Interactive Interpreter, and I'm going to create a list. We'll call it board because ultimately that's what we're going to be using as the name. And I'm going to create it as a list, and here are 3 elements, right? And so again, these aren't the elements that we're going to be using, but I'm just showing you that is a list that contains 3 elements. If I say board, you can see it lists it out. Each of the elements is an integer, right? The numbers 1, 2, and 3. But let's read a little bit further here in the description. It says, while each element is another 3-element list, the inner lists, the 3 of them, represent the rows so that all of the squares may be accessed using the following syntax. And we would say board as the name of the list, the row being either the 0 index position, the 1 index position, or the 2 index position, followed by the column. In other words, that number that would be in that column. And so let's go ahead and let's create real briefly what we think that board might look like, right? So if I was to say board, and then let's sort of recreate it. So here's the list board. Now, the 3 elements are going to be 1, 2, 3, right? There's the first element. The second element is going to be 4x and 6. Remember, 5 is not going to be a number that we're going to be using or that would ever be available because the computer always goes first, and that is the spot which will always initially be taken. And then we have 7, 8, and 9. All right, so there is my 3-element list, and the name of the list is board. There's the first element, index position 0. The second element, index position 1. The third element, index position 2. Now, let's hit enter here, and let's, what did I miss? I'm missing something. Oh, sorry about that. I forgot to, let me copy this here and then go back. I forgot to put in, let's see if we can get over here, a little single quote. There we go. All right, and so we've got a list that's got mixed types. I apologize, I left out my single quotes there for the X. So if I was to say board now, you can see that each element is a list, and in that list, we have something that relates to the column. And so if I was to say board, and as they show here, the row, so 0, that is that first row, which initially would show the integers 1, 2, and 3. But what if I wanted to see just the second column there, right? So, and this would be in that column, that second column, I would say board 0, which gives me the first row, and then 1, which gives me the second element at index position 1. And so here is how I could access, and this is also how I could update the values that are in this list. For example, what if I was to say board, and then let's change, let's say board 0, 1, and let's say that the user had their turn and they wanted to put an O, right? Because the user is going to be an O. And I'll hit enter, and then we say board, and you can see that the board has now been updated. Now, again, we're not drawing the board out just yet, but I want to give you a flavor as to how this might proceed, right? How each turn may proceed. And you can see I'm simply updating the elements inside of the list, which is an element in the greater list for the board. So, excuse me. So now the question becomes, how would I print all of this out? So let's tackle this initially by doing the following. And I'm going to use the area, the space up here at the top. That way we don't start having to go up and down in this file. And so let's go ahead and let's declare the board to be exactly what we declared it over here, which is simply that 3-element list. Now, remember that inside the function, typically we have a concern of scope, right? Where you can't change, like let's say we had a value X that was an integer value. And in the global namespace, in the larger program, that value had, and actually, let me just do this. Let's demo this, right? So here's what I'm saying with scope. So if I was to say X equals 5, right? That's what it is in the global namespace. But if I create a function, right, and we'll just say myfunc, and it takes a single argument that's going to send it in as a positional parameter, and then I was to say something like this, print the value of X is currently, and we'll do this, X, right? And then I was to do something, I didn't want to do that, I apologize, it's not going to let me. So if I wanted to do this and then say print, and we'll just shorten this up, the value of X is X, and then I change the value of X here and make it this, just a whole bunch of 9s, right? And then I say print the value of X is now. So there's a function, right? It's going to print the value of X when it gets passed in. I'm going to change the value of X inside the function. I'm going to print the new value, but what we're going to see is that that does not impact the value of X in the global namespace. So in other words, think of it as this is taking place in its own little hermetically sealed bubble. Now, Could we use some kind of a keyword like global to change the behavior? We could, but by default, as it stands, watch what happens here. So I say x. You can see that x is 5, but when I call my function and I pass it x, which initially is 5, watch what happens. You can see that the value of x is 5 when I pass it in, because that's what it is here in the global namespace. And so that value gets carried in here. Then I change the value here, but am I really changing the value of the original x in place? And the answer is no, I'm not, because when I hit x in the global namespace, it is going to tell me the value is still 5, right? So what happened here with this immutable data type, an integer, is that I'm not able to change the globally defined value for x by manipulating this other x, which is inside the function. So think of the function as like this hermetically sealed little bubble. And it's kind of like the analogy I typically use with learners is it's like Vegas, right? What happens in the function stays in the function, unless we return something, or we could use the global keyword. But again, with what we have here, we are not changing what is in the global namespace. And again, this is has a lot to do with the fact that integers, just like strings, are immutable. They cannot be changed in place. And we covered that when we were using that ID function. Now, what about lists? Well, lists are mutable. They can grow and they can shrink. And so with lists, we can make changes to the lists or a list in a function, and that will affect the list itself. So let's take a look at what that might look like. And to do that, we're going to go ahead and we're going to transition over here to the chapter, or I should say the chapter, sort of the section here in the online course, right? Where we took a look in 4135, and they're doing a return here, right? So they're returning the list because the list is instantiated or created inside the function. And that, again, totally legit. You could totally do it that way. But what I'm going to show you is that we can create the list in the global namespace. We could then append something to the list in the function, right? And so that's another way to do it. And so let's go ahead and take a look at that in the interactive interpreter here, right? So if I'm in the global namespace, which I am, and I say my list, and again, we're just kind of creating this broken, junky list here that's empty right now. So there's my list. It's not going to do much for us, but it's in the global namespace. So now I'm going to create change list, which is going to be this function. And I'm going to go ahead and, we're going to allow it to take a argument, which will be a positional parameter when it gets passed in, called my list. And we're going to see that just like here in this activity, I can actually now go through and say for num in range, and we'll just put 0 to 10. And we're going to say my list dot append num, and we're not going to return anything, right? But watch what happens here. So if I say my list, if I say my list, you can see the list is empty. But what if I say change list and I pass in my list and a mutable data type, a data type that can be changed in place? Because when I call this function and I send in my list, what should happen is it should come out and the result should be that I have a list that now has the integer values 0 through 9, right? And let's check that out. And there it is, right? And so that's why it's a little different when we're working with a list, which is a mutable, right? Can be changed in place data type. And again, want to make sure we cover these things because these are the types of things that are going to come up. Now, there's also another one we're going to talk about here, and that is whether I should be using integers here or whether I should be using strings to represent those numbers. Now, I kind of gave it away there. I'm going to be flipping these here to be strings, but for right now, let's see what these look like as integers, and let's go ahead and try to print out the board. And so the thing I'm going to put down at the very bottom of the screen here, and let me see if I can speed this up a little bit. What I'm going to put down at the bottom of the screen is going to be the call that we will ultimately make to display board, and we will be passing in our board, which is our list right here. And so now we need the code that would print the current status of the board out. And this will be the current status of our board when the game begins. And so for right now, we haven't changed anything. That's going to be in one of these other functions. But let's get the board printed out. And I'm going to handle this with individual print statements because it's going to be easy for me to copy and paste things here, and it's going to look pretty nice. And so you can see we've got a print statement. Well, let's go back over to the activity. Went right by it there. And you can see if we were to come back here, and actually let's go all the way to the top to the initial board. And so that is going to be the first line. And so I'll copy that, come here, and I'm going to paste that in here, right? Whoops. And I'm going to paste that in there. So that would be our first line. And then I would say print. And then the second line, right, is simply going to be these pipe symbols. Now remember that spacing, in order to make it look nice and pretty, is going to be important here when we get on to the next set of lines. And so there's our second line. So let's save this. Let's hit F5. Let's hit OK. And you can see expected indented block. And what happened there? It's highlighting the def that is here. And let me see, let me pull these out. We're not even going to be working with those right now anyway. So let me make sure that it's not something that happened when I did a cut and paste operation, which has happened before. All right, display board. Oh, I'm sorry. Displays with a capital D. There we go. Let's sort that. And in fact, I don't like that. We're going to go with a lowercase. So I'm going to just change that function call, change it to a lowercase d, and let's see what we get. All right, we'll take a look at that. So we're off to a great start right here. Now, it's going to be the next line here, right? And this is going to be a tough one. And I'm going to copy that line. And this is where we have to probably stop and pause and do a little bit of thinking here. Because if I do this, what's the problem here? Now, it's going to look really nice. And this is a mistake that learners typically make, is that they do this, but then they can't figure out why they're unable to update these values or to change those values, right? So remember, this is where the row and column of the board list are going to come into play. And so here's what I mean by this. If I was to say, we're going to put that there, but I want the value, right? I want the current value that would be in this first row. I want that value for first column, second column, third column in the first row. Well, how do I access these? Well, we already talked about that. Whoops, sorry. We already talked about that kind of right over here. So what if I was to do this? What if I was to put the pipe and then say 1, 2, 3, and then end it, do concatenation, and say board 0, 0. Whoops, sorry, 0, and I forgot the 0. There we go. 0, 0, and then concatenate that to, or I'm sorry, what do we want? I want to make sure we've got 1, 2, 3, and then the pipe. In fact, let me pull the rest of this back here so that it doesn't get in the way. All right, so then we're going to concatenate that to 1, 2, 3, and we'll put the pipe in here. And you might see the problem we're going to run into with integer values up here, along with that string value here and the fact that we're concatenating some of these values. And again, I want to force us into the air so we can talk about how we can deal with it. All right, so that is what we're looking at first. Actually, I'm sorry. Come back here. So we'll say 1, 2, 3, and we'll put that, and then let me make sure I've got that right. And then 1, 2, 3 with the pipe, 1, 2, 3 with the single tick, and then the concatenation, and then 1, 2, 3. We'll put board 0, 1. Oops, keep forgetting to do the bracket on the second one there. So we have board 0, 1, and then concatenate that to 1, 2, 3, and then we'll put the pipe 1, 2, 3, and then we'll concatenate that to board. Where are we at here? 0, and then let's get the brackets in there, 0, 2, and then concatenate that to pipe 2, 3. That, and so we should, and again, we might have to touch this up just a little bit, but you can see that what are we printing here, right? So this is going to be a dynamic displaying of the board, because whatever the values are in the list board for each of these sub-elements in the list, which we will be changing, when we're using the other functions that are going to be part of this program, they'll be updating. So now, again, I've already told you we're going to run into some issues here. And that's what I want to discuss. And what's the problem, right? Can only concatenate strings to strings, not to integers. So how could I handle this, right? Well, I could do this. I could do explicit typecasting, right? Type conversion here, or typecasting, and convert those values into strings, these integers into strings down here in the print statement. And let's see what that looks like. But you can see the problem with this, right? Is it's adding a whole lot of text to a whole lot of text. So str, and then we'll come all the way down here. And now let's hit F5. Let's save it. And let's see what we get. And again, you can see we've got some work to do here to sort of sort this out. My spacing was spot on here initially, but then we kind of got off. Looks like after the 2 or the second one, it's going to be 1, 2. Let's see if that was what I was missing there. At least I think that is the one that's going to need to change, and it is. Okay. So take a look at that, right? I mean, fantastic. But do we need to do the conversion down here? So that's a question for you, right? How would you want to handle it? We can leave integers up here, but we've got a string, and we're going to be dealing with strings in terms of the characters, right? The X's and the O's. And so my recommendation, and what I would be looking at in a final solution, and I think we're good there, is going to be the following. Now, this is obviously going to take a little more work up front to do these as strings. They're going to be displayed. Remember, they'll be displayed as integers, right? Or they'll appear to be integers because they're not going to have the single quotes around them. So let's hit F5 and let's rerun this. And you can see, right, it displays them and they look like integers, right? So they don't look like strings. But behind the scenes, we're going to deal with these as strings. And so with this done, we're pretty much done here, because watch what I need to do. I just need to copy this, and we'll come down here to the next line and we'll paste that. And then there's the break set up here. So we'll copy that and then paste that. And then for the next line that's going to be inside my board, we're going to copy that and paste that. Now, remember, I told you the patterns that we were looking at is going to be 0, 0, 0, 1, 0, 2. But then it's going to be 1, 0, right? Because we're in the second row, 1, 1, and 1, 2. So let's test. And again, highly recommend testing. Put the first 2 print statements in, test, see what it looks like. Make sure the pluses and the pipes line up. Then put in your first row of board values. Let's hit OK. And there we go. That looks pretty good, right? It's certainly starting to look just like the board that we want. And so then I need those 2 lines right there. And we're almost done here. Is that right? I got the lines and the dashes, and then we need the lines one more time. Or I'm sorry, I say lines when I'm talking about the pipes. And so there we go. And then we're going to have this line right here. But again, we need to make a minor modification to it. And I'll say V, and then we'll say, again, 2, 1, 20, 21, and 22. And so let's test. F5, see what we got. All right, looks pretty good. I think I'm missing, what am I missing here? There should be another row of the blanks. Yeah, I'm sorry, I'm missing a row of the blanks here, so we're going to grab that there. And again, this is why it's a good thing to test, and then we'll hit F5 here, and we'll click OK, and we'll see what we get. Oh, it's looking good now. And so now we're kind of down to the end, right? This is pretty much going to be the rest of what we need. So we're going to need that row of pipes, and then we're going to close things out with sort of the plus sign and the dashes. And you can see how simple it is here to actually create the board, right, which is this list with 3 elements, each itself a list representing a position on the board. And so now I'm going to hit F5. We're going to click OK. And there it is. And let's go take a look over here and see, how do we look? It is spot on right now. You'll notice I don't have anything that says entering moves, right? Because we're only dealing with the display board piece of the project right now. And that is actually spot on with what we're hoping to achieve. And again, I'll add in the next function when we get into part 2 of this video. But for right now, we've talked about some very important aspects of this program. We talked about the namespace, right? We talked about functions, and we sort of talked about the scope and how immutable data types are dealt with inside of a function, and we saw how mutable data types like a list can be manipulated inside of a function, and that is actually changing in place the list that we have defined globally. And so this first function is pretty straightforward. We have the dynamism, I guess would be the right word, but the dynamic aspects of this project are now sort of the foundational dynamic piece of this is set up so that whenever I call to display the board, inside the function where I update the board, we should then see this sort of new updated board as the board is updated move by move. All right, well, that is going to do it for this first of 5 videos that's going to break down this project little by little. And so next we're going to be dealing with entering a move. That function is going to accept the board's current status. It's going to ask the user what their move is. We're going to check input. We're going to update the board according to the user's decision, and then we're going to display the board with the update, right? So it would be something akin to the prompt of, hey, enter the move. You're going to type in the number that you're interested in, and then we're going to go in and make those adjustments and display the new board. All right, well, thank you so much for watching part 1 of Lab 4.1.6.13. Again, I know that this one is probably one that everybody's interested in seeing the solution